Hello, this HighByte video captures a solution for obtaining data from multiple process historians, normalizing that data, and populating a cloud analytics platform with a common data model. In this case, the solution pertains to Snowflake as the cloud analytics platform. And what you'll see in this video, both the slides and the demonstration solution, capture what we worked on with Snowflake for a company, a heavy process industry company that had aggregated data for a business unit in an enterprise historian, but that was aggregated differently for different business units. So they actually had multiple enterprise historians for different business units in different regions. And what we did was brought that data together in a common model. That's very typical for Intelligence Hub to be used to normalize data, abstracting data from its source system. And in this case, the common data model consisted of tables in Snowflake, and this is just a few of the tables. Tables for metadata, an example that might be a table for tag metadata. What is the tag ID? What is the tag description? What's the unit of measure? The data type, and maybe a narrow table containing value changes for all tags, for all historians, for the entire enterprise. And that is indeed what we did in the reference solution. So as you can imagine, was a significant number of tags, a high volume of data, and we brought all of that in this case, to one common table in this data model. Now, it wouldn't have to be a narrow table format. That's just one example. There could also be wide tables for a specific asset class, maybe for real-time updates, but we'll focus on these two tables for this example solution today. And just to take a look, so the solution, the Intelligence Hub part of the solution, providing data to Snowflake. In the reference solution, obtained data from a Honeywell PhD historian, an Aspen Tech IP21 historian, and an Aviva Pi system historian, including asset framework. In this example solution, which you'll see, we'll just focus on the data from data archive and the tag metadata and values. So in all cases, Intelligence Hub is used to create data pipelines that obtain data from the historians, and it's all done through configuration. And where we'll start with the tag metadata and what we call a model in Intelligence Hub. So here you can see the model that consists of a number of attributes, and those attributes are important because we're defining the schema of the table in the destination system, in this case, Snowflake. So we'll use different connection inputs to obtain data from historians. We'll connect to IP21, and we'll use our Windows service, what we call our IP21 connection agent, to obtain data from IP21, and that allows us to create queries. In this case, we've created a query that obtains the metadata from IP21, and you can see here we have the name of the tag, the description of the tag, its type, engineering units. And as we move through these different solutions, you'll see that in each case, the historian returns slightly different data. It's always returned in a different format. And that's really what we have to do in Intelligence Hub, is normalize those to that data schema. So here I've connected a Canary historian using the Views Service API. And we'll use the Intelligence Hub REST connection input to do that. Once we've created an input, I can use a method for that API, in this case, the get tag properties method. And I've just filtered here by a path and a tag filter. So I'm searching for all the pumps in this solution. And again, I'll pull back the data, the metadata for the tags. And then finally, we'll work just with Pi data archive. Our Pi connection agent uses the Pi AF SDK, and we use a Windows service that provides the ability to connect through that Pi AF SDK. Authenticate with Pi credentials here. Once I create an input, I can browse the asset framework structure. In this case, we'll just work with a specific set of points that I can query based on a known naming convention for the points. And when I test again, you see that I have an array of point metadata, including the description, the data type, engineering units, etc. Okay, so those are my connections. Remember, just going back again, we want to use this lens of a model, and we'll use pipelines. Pipelines are assembled very quickly and easily through dragging and dropping stages onto a canvas, and that's what I've already done. I've just gone through and used some of these stages that I pull and I configure on the canvas. We're not going to spend too much time on that today learning about pipelines. I'll enable this pipeline. This pipeline runs infrequently because the metadata typically changes infrequently. So this might run once a day, once a shift, maybe even less frequently than that. It's run once, it's identified 280 tags, and it's written those to Snowflake, all their metadata. What I do is, I read that connection input that I've already shown you, break up the object in this case, and and then I model. And that model that I referenced, I just use that as the data moves through, I map it into that model. So my high and low values, and then I'm just hard coding the source so that I know where the data came from. So that's going to be sent to Snowflake, and it's going to be sent using our Snowflake, in this case, SQL connection, which is a JDBC connection. I've already made that connection here. I just identify my Snowflake account, and then I create a connection output. And in this case, I've already created a table. The connection output could create the table. Here I've chosen to do an upsert. I just want to create a row in a table for every tag ID, and that's what I'll indeed do. So we'll take a look at that in Snowflake. And if I think I was looking at Canary, I think that's what I enabled. So I have a table here that will contain tag metadata, and you can see there's my tag ID, the description, the type, units of measure, high, low, and the source. So what I'll do now is we'll come back to this, but I have pipelines that will return the data, the tag metadata for PyData archive and also IP21. They're very similar. I'll enable those. In each case, they obtain the data from the respective historian. If it is returned as an object or array, it breaks that up, then moves it through this model that I've already shown you, and then writes it to Snowflake. Okay, so let's take a look at the tag data, the values that we want to send. And again, we have a model, and it's intentionally very simple. We just have a tag ID because we don't need much context because we're going to relate in Snowflake to that metadata table that has all of the information about a respective tag. Then I'm merely going to decide is the value a number or not, and then assign the timestamp from the historian. And I'll just use the source again so I know, for the purpose of this exercise, where the data originated from. Again, we need to connect. So in the case of our connections that we've already established, I can read from Canary, the values. I'm going to read values for a time span. So I want to get all of the value changes. So I'm going to use like a rolling time frame to get that. And I'll pass the start and end time from the pipeline. And this is how I'll do this. So I have the get tag data method for Canary, and then I pass the for my pumps again, but I'm passing the start and end time into this query from the pipeline. And the same will be true with each of these different connections. I have my input that I've created for the time span from IP21. So there again, I pass the start and end time from my pipeline, and I use it in the query. And then finally, there's methods that we could alternative methods that we could use here with uh, Aviva Pi system. The input types are a bit more diverse. But in this case, we'll just, again, use a time span. We'll pass the time span. Here I've just, provided some default values, but it's all parameterized, and those will be passed from the pipeline into this connection input. So let's take a look at one of these pipelines. So if I go to my read my time span values, and we'll just click right here on the Pi example because it's convenient. I'll enable it. And what that's going to do is it's going to save the start time, the last start time that this pipeline executed, as a state variable. And then it's going to read and pass the start and end time. So I have some JavaScript here that I'm using to get the start and end time for each time this pipeline executes, we pass the start and end time into the read. We get back an object per point, break that up. We get an array per point, break that up. And then I determine if it's a number or not, or text, or other, I should say. And then we just do a mapping here into the model. And then it's often a good practice when we're dealing with a significant amount of data to buffer in front of, create a batch of data that we send to Snowflake, and then we write it to Snowflake. And here again, we have the ability to define the table with the schema. I've already defined the table. I can just identify which table I'm writing to. But here we're using Snowflake streaming connection, and this connection output is highly performant. So this is not a JDBC connection. This is using the Snowflake streaming API, and we can write a lot of data through this connection output. So that's what we'll do. The pipeline has been enabled, and we should see data. I'll use Pi. And let's take a look at the tag values table. So here we can see it's just a tag ID. It's a narrow table. We have the numeric. In each case, these are numerics, the time and date stamp. This is actually coming from Pi, which is what we'd want. And you can see the data there. So I'll just enable these other pipelines, and then we'll do some just real quick checking and wrap up. So I've enabled the pipelines. So now we have data coming from each historian into these common tables. So we previously looked at the metadata for Canary. We should be able to have some metadata for the Pi system. It may not have updated yet. There we go. So there we have some IP21 data. So these are the tag metadata values coming from IP21. So we have Canary and Pi and IP21 in that table. And let's see if we have our data. So these are our values, which we've already looked at for Pi. I think I forgot that I already did that. Well, let's look for IP21. IP21 is the source, and then also Canary historian. So in this one table, we have normalized data from many historians, and we can trend maybe across like a specific process parameter type, for example. And this might even be data coming from similar Canary historians, perhaps, that we're combining here as well. So in summary, a real world project where Intelligence Hub was used to obtain data from many historians, normalize it, and write it into common tables uniquely defined for the requirements. In this case, in Snowflake, but it could be any analytics platform, data lake, data warehouse. Thank you for your time.